This lecture is going to talk about the last two steps in hypothesis testing. Step 4, which is making a decision based upon the information we've gotten from step 3. And step 5 is stating a conclusion based upon our original claim, and our decision from step 4. So let's go look at the notes for both of those. We'll start with step 4 and making a decision, and let's go there. Okay, how do we make a decision? Well, remember in step 3, whether you're using the p-value approach or the critical value approach, that we were trying to determine if the test statistic we computed in step 2 was unlikely, okay? Because if it's unlikely, that means we're going to end up rejecting in step 4. So step 3 was determining if the test statistic was unlikely. So in making the decision, we basically take the results of step 3 and we state a decision, and there are only going to be 2 choices here. Exactly 2 choices. And the structure of these 2 choices is important. We're either rejecting H0 or failing to reject H0. But when we make a statement about rejecting or failing to reject, we need to state a reason for it. Okay? And so the numbers that we come up with, that we use to determine if the test statistic was unusual or not, are going to be used in our decision as well. Okay? In other words, the test statistic that we have is going to be compared to a critical value, if we use the critical value approach, or the p-value that we have is going to be used and compared to alpha, okay? And that's how we're going to give a rationale for rejecting or failing to reject. So we want to say reject H0 because, and then we'll basically be looking at those problems, those examples that we have been working through, and we'll make our decision and use the numbers that we have from that, okay? And if we were, and here's some examples here, if we were using the critical value approach, we might have an example where we reject H0 because the test statistic is greater than the right tail critical value. In other words, what we would do is we would take the actual test statistic value and say this number is greater than, and the right tail critical value is the number we would put here instead of the words right tail critical value. So we're going to use numbers in our decision. And if we fail to reject, it's because the test statistic is, where is it relative to the critical values? If it's a two-tailed test, it would be between the critical values. Or we might say that if it were a left-tailed test and the critical value is farther out away from the mean than the test statistic, that the test statistic is less than the critical value. Along those lines, that's how we would make our statement. But we have to keep in mind, have a kind of a mind's eye looking at that picture in our brain of the graph, where is the test statistic relative to a critical value. All right, and if it were a p-value approach, we would reject because the p-value is less than or equal to the significance level, and we would use the number for the p-value and the number for the significance level in there. And if we fail to reject H0, it's because the p-value is greater than the significance level, and we would use the number for the p-value and the number for the significance level in there, okay? So let's go look then at the problems here and state our decision. So I'm going to stop the sharing of this, go and change my or rather I don't have to stop sharing. Sorry, I set it up better than I had it and forgot that I did it. So here we go. I already have these attached to the bottom here. All right, so here's our first problem. Again, it's a test of the claim. And let's say that we've got everything done here, all of step 1, all of step 2, and we've also done step 3, either one of these things or both. And another thing I need to emphasize here is unless a problem specifically tells you to use p-value or specifically to use critical value or give a critical value, you have a choice of doing either one, okay? You'll do one or the other unless it specifically tells you to do it specifically tells you to do one of them, okay? So let's say that we've got everything done here except this decision is empty, it's blank, and our conclusion is blank. So let's answer our decision for this problem right here. Well, we know that the p-value was 0.3180. And what do we always compare the p-value to? Alpha. If the p-value is less than or equal to alpha, and this remember is a rule that you have to memorize. If the p-value is less than or equal to alpha, we will reject the null hypothesis. We will reject H0, okay? So we would say, having this information right here, knowing that we got a p-value, we would compare it to alpha, and we would say then, we'll fail to reject H0 because 0.3180, the p-value, is greater than 0.05, okay? That's our decision. We're done with that. If we did the critical value instead, we find that the critical value is t equals negative 1.717. It's a left-tailed test. And we know that the test statistic is negative 0.480. We know that we would draw a sketch here if we hadn't already gone through all of this. We would draw a sketch and we would have the test statistic plotted, and we would have the critical test statistic plotted and the critical value plotted. And remember, we have the mean as a reference here. We would have said that, we would say that, well, the test statistic is not in that critical region. So the critical value on the left is less than the test statistic, which will cause us to fail to reject because it's test statistics not unlikely. So our decision would say, again, fail to reject H0 because negative 0.480 is greater than negative 1.717, or I would say that negative 1.717 is less than negative 0.480. Either one of those is correct. You can flip those around, including flipping the inequality, and you have the same value, okay? The same, it's stating the same thing. It's the same logical sentence, okay? Or mathematical sentence, okay? So that's how we would do that. Again, fail to reject H0 because, and then we'll make a statement about, is the test statistic farther from the, in using numbers, is the test statistic farther from the mean? If we fail to reject, is the test statistic closer to the mean than the critical value on that side? Or in the p-value case, is the p-value less than or equal to or greater than alpha if we fail to reject? Okay. All right, let's go to the next one. Again, let's say that this decision and statement of conclusion is all blank. So we look at the p-value and we look at alpha, p-value compared to alpha. This is bigger than alpha. Therefore, we will fail to reject because that test or the p-value is greater than the alpha value. And it's a right-tailed test. And so we get a critical value of 76.154. We compare test statistic to that. if we put them on a graph, we see that the test statistic is closer to the mean than the critical value, or it's less than the critical value on the right. Okay. The best way to think of this is if it's a left-tailed test and you fail to reject, you would say that the critical value is less than the test statistic. If it's on the right, you would say, if you fail to reject, the test statistic is less than the critical value. Okay? And if you rejected, you would say that if it's a left-tailed test, that the test statistic is less than the critical value on the left side. If it's on the right side, you would say you rejected because the critical value is less than the test statistic on the right. Okay, so we would say in this case, fail to reject A0 because the test statistic is less than the critical value on the right. Let's go to the next one here. We ended up with a p-value of 0.0490 and alpha is 0.05. So we know that the p-value is less than alpha, which means that the test statistic is unlikely. It means we're going to reject H0 because 0.0490, the p-value is less than 0.05 alpha. And the critical value, it is a right-tailed test again. So the test critical value is on the right, and we would plot the critical value in a picture. We would plot the test statistic, and we would see that the test statistic is just slightly bigger than the critical value, and we would reject A0 because actually we would say that the critical value is less than the test statistic, but that's the same as saying that the test statistic is greater than the critical value. Either one of those is going to be good, but the relative positions has to be indicated in this inequality right here. And then the next one, this is a test of the mean, and it's a two-tailed test. So we had to find the p-value, which turns out to be 0, and we compare that to basically any alpha, and we see that the p-value is less than alpha. Therefore, we'll say reject H0. The test statistic is unlikely. Reject H0 because the p-value 0 is less than 0.05. Or we would say, since we have two critical values here for a two-tailed test, and we plot the test statistic, and it is much farther away from the mean than the left critical value. Therefore, it is less than that left critical value. So negative 4.733 is less than negative 2.042. That would be the reason for rejecting if we use the critical value approach. And let's look at the last two here quickly. Test of proportion. It's a left-tailed test. We find the p-value in step 3 is 0.0721, and the significance level alpha is 0.05. And since it is bigger than 0.05, we'll fail to reject H0. The test statistic value is not unlikely. We'll fail to reject H0 because the p-value 0.0721 is greater than 0.05. And a left-tailed critical value is negative 1.645. We plot that, we plot the test statistic, and we would fail to reject because the test statistic is not unlikely. It's not in a rejection region. We would say that negative 1.645 is less than negative 1.46. The critical value is less than the test statistic value on the left. Okay. And finally, we have a two-tailed test. We have the p-value as 0.0286 and the alpha significance level 0.05, and it is less than 0.05. That means that the test statistic is unlikely to have occurred if the assumption is true. And so we're going to reject H0 because the p-value 0.0286 is less than 0.05. If we use critical value approach, we see that the two critical values are negative 1.96 and positive 1.96. We plot one of those, or both of those, I'm sorry, and then we plot the test statistic as well. And we see that it is in a rejection region, and it, as a matter of fact, is on the left. It's farther from the mean than the left critical value. So we're going to reject 8.0 because the test statistic, negative 2.19, is less than the critical value, negative 1.96, on the left. And that is how we would make our decision based on either the p-value or the critical value. So let's go back up then and look at the last item in the step 5 in hypothesis testing, and that is statement of conclusion. And this should be the easiest of all the steps because it's canned. All we need to know is, did we fail to reject, or did we reject, or did we fail to reject? And we also need to know, did the original claim include equality, or did it not include equality? Remember, less than, greater than, and not equal do not include equality. Equal, less than or equal, greater than or equal do include equality, okay? So we look at the results of our step 4, our decision, and we go to, there's a table here that has the wording for it. And I'll use this table for stating our conclusion. And let's look at what we got here. If we fail to reject 8.0 and the original claim includes equality, then here's the wording that you're going to use. There is not sufficient evidence to warrant rejection of the claim that, and whatever the claim was, we'll repeat the claim right here. Okay, so your wording is pretty well canned. You can't mess it up. Just make sure you copy it correctly from this, either this table or the flow chart that you will have, that you have in your formulas and tables handout. And we'll take a quick look at that as soon as we go through these 4 things and look at the problems, okay? If we rejected, but the original claim includes equality, we'll say there is sufficient evidence to warrant rejection of the claim that, and then we'll state the original claim there. If we fail to reject 8.0 and the original claim does not include equality, we'll say there is not sufficient evidence to support the claim that, and we'll repeat the claim here. If we reject 8.0 and the original claim did not include equality, we'll say there is sufficient evidence to support the claim that, and we'll state the original claim back over here. You'll notice that if the claim includes equality, either, no matter what, whether we reject or fail to reject, we're talking about warranting rejection of the claim or not warranting rejection of the claim, okay? So, and if we are, if the claim does include equality, it's all about whether we're supporting the claim or not supporting the claim, okay? So let's take a peek at these problems, all right? Our decision in this one is we failed to reject 8.0. The original claim was mu less than 70. So we're basically saying there's not sufficient evidence, and I'm calling it sample evidence. There's not sufficient evidence to support the claim, and then we repeat it, mu less than 70. In this one right here, we failed to reject 8.0, and the claim, again, did not include equality. So there is not sufficient sample evidence to support the claim that sigma is greater than 1. Basically, that pretty much says the same thing that's in that. If you're taking the test on test 3 online, note that you will have like 4 options. It will be multiple choice as to which one you're going to use. Or it may be a single line, but it has drop-down words. So it should be fairly easy. This is pretty straightforward, and you shouldn't have any problems with stating the claim. Okay, so now let's look at the next one. We reject 8.0. The claim included equality. So I'll tell you what, let's go look at what we would say. We rejected and it included equality. So if we go back up here, we reject and it included equality. Here's the wording: sufficient evidence to warrant rejection of the claim that, and we repeat the claim. Let's see what I wrote in here. Sufficient evidence to warrant rejection of the claim that, and then I repeat the claim, sigma less than or equal to 0.15. And then let's look at this one. Decision was again reject. It is, and the claim included equality. So basically it's the same wording. There's sufficient evidence to warrant, the alternate hypothesis. The claim included equality. This is incorrect. I found an error in my notes or in the problems here. There is sufficient evidence to warrant rejection of the claim that the mean is equal to 6.67. So let's go back up. We rejected and it included equality. It should have said sufficient evidence to warrant rejection of the claim. I got it wrong. So I guess I'm not going to get 100%. All right, so that was this one here, or was it this one? Equal, yeah, okay, so it was this one, the fourth one. All right, let's look at the fifth one. Let's see if I can get this one right. Again, claim includes equality, but we failed to reject. So what are we going to say? There's insufficient evidence. There is not sufficient evidence to warrant rejection of the claim. I got this one right. Okay, that, and we repeat the claim, P greater than or equal to 0.7. And finally, this one, it's the claim did not include equality, and we're rejecting. So we would say that there is sufficient evidence to support the claim that P not equal 0.13. We repeat the claim down here. Okay, so here I am telling you this is the easiest thing, and this is the one thing that I make a mistake on. So, not good. Okay, you're going to do better than that. All right, so now the one thing I want to do, the last thing I'm going to do here in hypothesis testing structure is go show you that the flow chart in the I got to go make a change here. Where are we here? Hang with me for a second here. Here we go, formulas and tables. And now let's go back and share this. Okay, formulas and tables handout. Let me quickly show you one thing here, and that is in chapter 8, formulas. We see that we have the test statistic formulas written in here. The Z is for test of proportion. The T is for test of the mean when we don't know sigma, which is all of our tests of the mean. And the chi-squared for standard deviation. So we go to the back of the second sheet in the formulas and tables handout, and at the bottom we see the hypothesis test wording flowchart. It asks us about whether the claim included equality or not, and then we go over, and then it asks us whether did we reject 8-0. If we included equality and we rejected, here's the wording. If it included equality and we failed to reject, then this is the wording. If it included equality and we rejected, this is the wording. If it included equality and we failed to reject, this is the wording. The only one that is different, slightly different here, is basically it doesn't say there's sufficient evidence to support the claim, okay? Other than that, it's still a true statement, okay? And that pretty much concludes our structure of hypothesis test. Step 1, step 2, step 3, step 4, step 5. And we have looked at a set of problems all the way through all 5 steps. So the next lecture is going to be to start talking about the individual hypothesis tests, and that's where we're going to talk about how we use tables and how we use calculators to determine if our test statistic is unusual or not. So until I get that one out, I will see you or talk to you later.